స్టార్ట్ చేసుకుందాం మేడం.
స్టార్ట్ చేద్దాం సార్.
ఓకే ప్లీజ్
ఓకే సార్.
ప్లీజ్.
So let us recall. In the previous class, we have discussed properties of a determinant. That's what we have discussed. And I have given one shortcut formula. Determinant of adjoint A, we have seen, is nothing but det A to the power of n minus 1. What is n? Order of A. Then we have discussed a determinant of Ka. This is very important. I said we are going to see the application K power n det A. So let us see one of the application. And when is it said to be singular? We stated matrix A is singular. A is a square matrix. It is singular if and only if determinant of A is equal to C. This way. When is it zero? Also, we have seen some shortcuts. If any row or column is zero, or any two rows are same, or any two columns are same, then determinant is zero. That's what we have seen properties. Now, let us see a question based on this. Yeah, here. Are you able to see this question? When you look at this question, the number of distinct real values of x for which this matrix is singular is. What is meant by singular? Determinant is zero. So the number of distinct real values of x. So we have to find x values, distinct x values, if this matrix is singular. Let us. So xxx, let us take this question. Determinant, you are given xxx, x11, is it not? This is the question I copied. x11, 1xx, determinant, x11, 1x1, 11x. This is singular. Singular means determinant is zero. This is the question. What is the question? If this matrix is singular, this is given to be singular, then distinct x values, distinct real x, we have to find. Number of distinct real x we have to find. So this is the question. The options are given. Let us see. So because it is singular, determinant must be equal to zero. Yes. So because this is singular, determinant must be zero. Singular means determinant is zero. Now find out the determinant. How will we find out? Directly also you can find plus minus plus, or apply some operations x plus 2 and then do it. Option is yours. How you do it? At present I am doing directly. X into x square minus 1. You know, all of you know how to expand the determinant. So minus 1 into x minus 1 plus 1 into 1 minus x is equal to 0. So this will be x minus 1 x cube minus x minus x plus 1 plus 1 minus x is 0. So this implies x cube minus 3x plus 2 0. So now how many real values are there? How many distinct real values? So this is a cubic equation. We will get 3 roots. So we have to find what are the 3 roots. How to find out 3 roots? Actually, it is a cubic equation. Therefore, how many roots it will have? 3 roots. So what students will do is, what are the options that are given? Number of distinct real values of x. So option 1, 1, 2, 3, infinite. So most of the students, they will write, because it is cubic equation, the so-called intelligent students, they will mark 3 directly. Because real values are here, 3 cubic equation, therefore 3 roots it will have. They will not read this. Simply they will read this singular. Then they will answer. Therefore, you have to read the question carefully. You are not asked to find how many values of x are there. How many distinct, that too real values. Complex are not allowed, repeated not allowed. Therefore, you must be very careful. So you should not opt third one. Because 3 distinct, we cannot say it may be correct, but we cannot answer from here. How to get to roots, inspection method. So, inspection method means for x equal to 1, we keep on substituting until we get 0 equal to 0. So, what we observe is 1 minus 3 plus 2, LHS. Put x equal to 1, this is 0, which is same as RHS. Therefore, x equal to 1 is 1 root. How to get remaining roots? Apply synthetic division. After x cube, x square not there. My x coefficient, put 0. What is 1 plus 0 here? 1 plus 0, 1. This is 1. This is 1. This is 1. Minus 2, 2, 0. If your answer is correct, last will be 0 always. So, cubic equation, when you divide one time, you will get second degree equation. So, this is x square coefficient. This is x coefficient. This is constant. So, what will be the equation? X square, x minus 1 into x minus 1, x equal to 1 is root means x minus 1. What will be the factorization for this? X square minus plus x minus 2 is 0. X equal to 1 already we got from here. Already we got. This we have to solve to get remaining roots. So x square plus x minus 2, 0. So x plus 2 into x minus 1. Factorization. So x equal to minus 2, 1. So what are the distinct value? What are the values we are getting? The values we are getting are x equal to 1 comma 1 comma minus 2. How many values means 3? Because cubic equation 3 roots. Roots may be equal, roots may be complex, roots may be distinct. So 3 cases. Here, how many distinct real values? All the 3 are real. How many real values means answer is 3. Please pay attention here. All of you can do up to this. While marking the options, you must be very careful. How many real values means 3. 1 is real, minus 2 is real. How many real roots means answer 3. How many distinct real roots? Distinct means how many? Only 2. 1 is repeating, minus 2 is different. So how many distinct root means there are only 2 distinct real roots. So 2 distinct real roots. What are they? Namely 1 comma minus 2. So how many are there? 2 are there. What are they? 1 and minus 2. So which answer correct? How many real roots are there? Distinct real roots. B option correct. 2. Otherwise, what will you write? 3. Some students will write because here it is 3. Cubic equation, therefore 3. Intelligently they are doing. And more intelligently, students will be falling into this. Here 3 values we got, they will forget by the time they get the roots. So they will answer that 3 are there. The answer 3, C option, which is not correct because distinct real. Only real means 3. Distinct real means 2. This is the answer. So simple questions like this you may get in the exam. Applications, application orient. Given this, you may be tested in theory of equations also, because unless you know how to solve cubic equation, you will not be able to answer this question. So this is how we got the answer. Let us see the application of this. Yeah. Question.
కాపీ చేసుకోండి మేడం, కాపీ చేసుకుని అక్కడ పేస్ట్ చేస్తాను.
అది చేస్తాం. So let us see that. So let us see the question.
Oh.
So okay, let us. I'll copy this.
Down.
Snip. I'll use this. Snip 2.
Okay.
So let us go for this. It's not LI. Total. So anyway, let us take this total. This is the question. Anyway, we have to answer this also. This is the question. 7th one. Determinant of adjoint A is 7th one. It got copied there. Just yes.
Yes.
Options also I want. Take this.
Right hand మీద question కనపడుతుంది కదా, please try.
So you can try.
Copy the question and try again.
Here it is. So look at this question. So determinant A is given, determinant of adjoint A. So A is a 4x4 matrix here. 4x4. So N is 4. What is determinant of adjoint A formula? You need not calculate adjoint A and do it. Determinant of A to the power of N minus. So dot A to the power of 4 minus 1, which is det A. So here we got this. So in order to find out this, we have to find det A. Problem is how to find det A. Here, determinant of A. This is 2135, 0417, 00.
It is upper triangular.
Yeah, good. That's what I'm saying. So just I'm copying that. Then I want to teach them the shortcut. 000 minus. So what we observe is, as somebody said, this is principal diagonal. This is what is called principal diagonal. 2, 4, 3 minus 4 is principal diagonal. Below the principal diagonal, all the elements are zeros. This is called principal diagonal. All of you know. Below the principal diagonal, everything is zero. If below the principal diagonal, everything is zero, such a matrix is what is called upper triangular. Below the principal diagonal, everything is zero, upper triangular. Suppose above is zero, above principal diagonal, then it is called lower triangle. And if above and below are zero, then it is called diagonal. So there are 3 types of matrices: upper triangular, lower triangular, and diagonal. If you get any one of these cases, diagonal. In any one of these cases, diagonal matrix. This is called upper triangular matrix. Below the principal diagonal, everything is zero. Lower triangular means above, all these are zeros. Suppose above is also zero, below is also zero, then it is called diagonal. In any case, there is a shortcut for finding determinant. What is the determinant is? Product. In all these cases, det A is product of diagonal elements. Product of principal diagonal elements. So, what are the principal diagonal elements? 2, 4, 3, minus 4. This is principal diagonal. So, what is the determinant? 2 into 4 into 3 into minus 4. If it is not in any one of these forms, then how to find that we'll see later. By chance, look at the matrix. Don't be too sincere. So, look at the matrix. If it happens to be any one of these, determinant is simply product of the principal diagonal. This is the shortcut for finding determinant. This is the one. Then this can be answer once You get this. This is 2. Answer is in terms of 2 power 5 into 3. So first, after getting the answer, go back to the options. So we have to get everything in terms of 2 and 3 powers. So here 4 is 2 square, and here into 3, 3 power 1. Here minus 4, so minus 2 square. So this is nothing but minus here 2 power 5 into 3. This is that. But we don't want this, sir. Some students, they'll forget the answer. They will answer this. This will be there among options. This is not the thing we are asked to find. We are asked to find determinant of adjoint A. So you can see first option is what we got. So it will be, so coincidentally you will get same answer. Same answer does not mean correct answer. So that A, more tempting option is kept as first one. So most of the students will feel very happy and they will answer this, which is not correct, because we are asked to find not det A, determinant of adjoint A. So det A cube we have to do. Substitute there. So what is determinant of adjoint A? Determinant of adjoint A is det A cube, which is minus 2 power 5, 3 power 1 cube. So minus to the power of odd number minus 2 to the power of 5 3s are 15, 3 power 3. So 2 power 15 into 3 cube with minus sign. You can see again here examiner has not given, but here sometimes it may be given 2 power 15 into 3 cube. With the plus sign also it may be given. With the minus sign also it may be given. So which is correct answer is C is the correct option. Minus 2 power 15 into 3 cube. This is tempting option, but not correct. This is the one. So after doing some steps, you will forget the question. So before marking, go to the question, see what we are asked to find. Then only mark. Otherwise, after doing so much, you may go wrong. This is known better. Known things you should not do mistakes. So be careful. So ఒకసారి ఆన్సర్ వచ్చాక క్వశ్చన్ వెనక్కి వెళ్ళండి. సో ఇక్కడ ఆన్సర్ ఇది మ్యాచ్ అవుతుందని పెట్టుకోవద్దు. సో చూసుకోండి ఏం కనుక్కోమన్నారు, అది ఇంపార్టెంట్. ఓకే, అన్ని ఆన్సర్స్ మీకు మ్యాచ్ అవుతాయి. మనకి ఏమవుతుందంటే జనరల్లీ రెగ్యులర్ ఎగ్జామ్స్లో మన మ్యాథమెటిక్స్ స్టూడెంట్స్కి జనరల్గా ఒక హ్యాబిట్ ఏంటంటే చేస్తాం క్వశ్చన్ వెనకాల ఆన్సర్స్ చూస్తాం. ఇవి రెండు మ్యాచ్ అయితే మనది కరెక్ట్ అన్నట్టు మనకు ఒక ఫీలింగ్. సో దాన్ని అడ్వాంటేజ్గా తీసుకొని జనరలీ పేపర్ సెట్టర్స్ ఫస్ట్ ఆప్షన్స్ అన్నీ కూడా అలాంటి టెంప్టింగ్ ఆప్షన్స్ పెడతారు, అంటే మ్యాచ్ అయ్యేట్టు పెడతారు. సో మనకి చూడండి డెటియాకి మ్యాచ్ అయింది అది. సో మనకి మ్యాచ్ అవ్వగానే మనం అదే కరెక్ట్ ఆన్సర్ అనుకుంటాం ఆ హ్యాబిట్ వల్ల. సో బీ కేర్ఫుల్. సో వాట్ వీఆర్ ఆస్క్డ్ టు ఫైండ్ దట్ విల్ బి దేర్. ఓకే, నెక్స్ట్ one. So this is the application we have seen. Then determinant this we completed. We want to again have determinant of adjoint A. I think we have to go for rank of the matrix now. This is the time we have to go for that rank of the matrix concept. Yeah. And determinant of some nilpotent matrix is given to us. So here a matrix A is nilpotent if A power n is 0. We have seen for some n. Then determinant of A. What will be the determinant of nilpotent matrix? What is nilpotent matrix? A not 0, A square not 0, K is the least positive integer for which it is 0. Preceding to that, they are not 0. A is not 0, A square not 0, up to A power K minus 1 not 0. But A power K is 0. That is, K is the least positive integer. Then such that A power K is 0, then it is called nilpotent of index K. K is called index. After K, A power K plus 1, A power K plus 2, everything will be 0. That is the reason why you are given A power n is 0 for some n. So here for K it is 0, K plus 1 0, K plus 2 0, and so on. But among them, least is called as index. Then what happens to its determinant? Det A need not be 0, det A 0, det A less than or equal to 0, A is triangular. So a very important is determinant of nilpotent matrix will be always 0. For nilpotent matrix, we have two important. We have two important notes. What is the note which is very important? I will give you here. Please note down somewhere. Try to memorize. Okay, let us. Very important is its determinant will be 0. Not only its determinant. Can you see this?
Big Gen.
Yes.
Yeah.
Now, are you able to see?
No, మరి కొంచెం కిందికి లాను. down.
Yeah.
Yeah, now correct.
A
Yes, sir.
matrix A is nilpotent if A power n is 0 for some n is given, then det A need not be 0, det A is 0 and so on. This is the next question. So answer is det A equal to 0. So very important is note somewhere. If A is nilpotent, matrix, whatever may be the index, nilpotent matrix of index, anything, index K, whatever may be the index, whether it is K or N, anything, then it can be anything, then det A is 0. Always 0, whatever may be the index. Second thing is all eigenvalues will be 0. Eigenvalues we will see later in future, but you have some background. This is not the first class for you. So eigenvalues are 0, will be 0. All eigenvalues of are 0. Among options will be given index K, K eigenvalue 0. A is n by n matrix. So n minus K will be 0. K eigenvalue 0. None of them 0. Like that, all will be 0. Like that, options will be given. So all eigenvalues of A R will be 0. All eigenvalues of A are 0. If A is nilpotent, a determinant is 0. All eigenvalues of A are 0. Not only that, because all eigenvalues are 0, trace will be 0. Because trace is nothing but sum of the eigenvalues. So obviously, trace, which will be, trace is, two names are given for trace. Sum of the principal diagonal elements. Another definition is sum of eigenvalues. Two definitions are there. Sum of eigenvalues. If all eigenvalues are 0, obviously sum also will be 0. Therefore, it will be 0. Because all eigenvalues are 0. Therefore, if A is nilpotent, then what are all the conclusions we can draw? That A is 0, all eigenvalues of A are 0, trace A will be 0. Converse need not be true. Don't trace A is 0, therefore don't conclude A is nilpotent. That is not true. Trace A may be 0, A need not be nilpotent. But if it is nilpotent, definitely trace A is 0. Okay, so trace A is 0. If A is nilpotent, automatically trace A is 0. We have seen earlier, trace A is 0 for skew symmetric also. So converse need not be true. If trace A is 0, it may be skew symmetric, it may be nilpotent, it may be neither also. So we cannot conclude converse, but only one side. If it is nilpotent, then this will be true. So otherwise, you will be given again one more question. If trace A is 0, then A is nilpotent. First option. Second option, A is skew symmetric. Option C need not be. So I'll give you that bit. If trace A is 0. Am I okay na? A is nilpotent aithe definite ga that A is 0. All eigenvalues 0. Trace A will be 0. And this is the one. Next, if trace A is 0, here note, converse need not be true. Converse need not be true. What's meant by converse? If trace A is 0, can you say A is nilpotent means no, need not be. So if trace A is 0, then A is nilpotent, B is skew symmetric, C option, both A and B, Option D, need not be. Can. No conclusion. Can be true. Or none. None of these may be good. None of them. Or data inadequate may be good. So, no conclusion can be drawn because you cannot say it is nilpotent. Converse need not be true. And trace A is 0, we cannot say skew symmetric because skew symmetric has got some other condition also. A transpose is minus A, that is Aij is minus Aj. One more condition. Principal diagonal must be 0. Other diagonal element should satisfy some other condition. So trace is 0, but it need not be skew symmetric. Trace 0 does not mean nilpotent. Intelligent students, if they don't have clarity. So whenever I say intelligent, it does not mean they are truly intelligent. People who think they are intelligent. So confusion. Some students, they are overconfident. They know everything, they will think that. So, but concept is missing. So converse need not be true. They will write both. Because nilpotent madam has given trace here 0 nilpotent, something vague. Vaguely you remember. This also. Therefore, you may answer A and B. So be careful. No conclusion can be drawn or none of them. This will be the answer. This is how questions may be given. So be careful. Next one. Here, because contest has come, I want to give some important things. If A is idempotent, this also may help you. Try to memorize. If A is idempotent, any one of you, can you tell me when is it idempotent? Do you remember idempotent? What is idempotent matrix? Satish and others. Do you remember what is idempotent?
Mute లో పెట్టిన మేడం ఇస్తున్నాను.
Okay, sorry. Okay, I'll proceed. A is idempotent means A square equal to A. Then it is said to be idempotent. If A is idempotent, then det A will be either 0 or 1. Remember this, be careful. A is idempotent, then det A is either 0 or 1. What is idempotent is A square is equal to A. If A square is equal to A, we call it as idempotent. If it is idempotent, you need not, for every idempotent matrix, determinant will be either 0 or 1. Why is it so? Would you like to know? Only for this I will show. Remaining I will give as just bits to remember. How did we get this result? Suppose in the interview, they ask you to prove if A is idempotent, what are the possible values of determinant means either 0 or 1. Suppose they ask you to prove. How are you going to prove? So A is idempotent. What is the proof? A is idempotent means A square is equal to A, which implies det A square is det A, which implies det A whole square is det A, which implies det A square minus det A is equal to 0. So det A, if you take common, det A minus 1 equal to 0. So det A is 0 or det A is minus plus 1. So what are the determinants? Either 0 or 1. This is how we got the answer. So don't conclude only 0.
Sir, excuse me, sir.
Cheppandi.
Sir, please tell previous proofs also, sir, if it is possible.
If it is possible.
Yeah.
This is not the this is not the platform actually. Nilpotent also. It's a very big derivation because for everything I cannot show because time problem. We have to complete the course. This is not the platform to give the proofs actually because this is not descriptive model. But not to leave you, I'm giving for some. For some of them, you try on your own because everything is not possible. What do you say, sir? Sir?
వెంకట్రావు గారు చెప్పండి.
అన్నిటికీ ప్రూఫ్స్ ఇమ్మంటారా లేకపోతే
పాసిబుల్ వెంకట్రావు గారు
నాట్ పాసిబుల్
దిస్ ప్లాట్ఫామ్
అందుకోసం
ట్రై సార్ మీకు కావాలంటే ప్రూఫ్స్ పెట్టిస్తాం ఏమంటే
అదే అవసరం. ఇప్పటికైతే మీకు టైం వేస్ట్ చేసుకోకండి.
Yes, yes.
ఇప్పుడు మీరు అసలు అందులోకి దిగద్దు. ఇది సిలబస్ ఒక మహారణ్యం. సో మీరు అందులోకి వెళ్తే బయటికి రాలేరు. ప్రతి సబ్జెక్ట్ కి
okay,
లోపలికి
thank
వెళ్ళే
you.
కొద్దీ డెప్త్
Thank
ఎక్కువ
you.
ఉంటుంది. మీరు పాస్ అవ్వాలి. మీ టార్గెట్ ఏంటంటే యూ హ్యావ్ టు క్రాస్ దిస్ ఫారెస్ట్.
Mhm. Yeah.
So you don't want to know nook and corners of each and every nook and corners of the total forest. So that is a different platform. ఇది అయిపోయి ఎగ్జామ్ క్లియర్ చేశాక ఫర్ నాలెడ్జ్ సేక్ యూ కెన్ go through the proofs. Okay,
Thank
but
you,
at present, because for the interview sake, I am telling in this one some like proofs which generally you may get in the interview. Okay, so this is the one. So it may be either 0 or 1. If A is idempotent, options will be given that A 0, first option, that A 1, 0 or 1, 0 and 1. 0 and 1, it cannot happen. Then 0 becomes equal to 1, which is absurdity. So either 0 or 1. So that's the answer for this. Next one. Determinant of if A is this is, we have seen involutory. Involutory. What is involutory? A square is equal to I.
A square is equals
A
to
square
I.
equal to I. Then determinant is plus or minus 1. Either plus 1 or minus 1. You can try. A square equal to I. Take determinant like I did. Next one. If A is orthogonal. Orthogonal means
A into A transpose
into
is
A
equals to I.
A transpose into A equal to I. Then that A. Then also that A is plus or minus 1. Then that A is equal to. Then we have involutory orthogonal. If A is our shortcuts are not there for all. If A is skew symmetric, very important. Skew symmetric matrix of odd order. That is n by n, where n is odd. The meaning is this. Odd order means n is odd. Then determinant is 0. Every skew symmetric matrix determinant is not 0. If it is odd order, if it is even order, we cannot say anything. We don't have any fixed result. If it is odd order, determinant will be 0. What is the best application of this? You might have seen. If A is equal to, for example, if it is skew symmetric and odd order, for example, if A is equal to 0, 0, 0, real. I'm talking about real skew symmetric matrix of odd order. Here 3 minus 3, 5 minus 5. Here some 100. Here minus 100. Then automatically it will be skew symmetric. Because principal diagonal 0, these two are having same value, opposite sign. Such a matrix is skew symmetric. So you should be able to identify the skew symmetric matrix. What is the order? 3 by 3. Order is odd order, and it is skew symmetric. So automatically that A is 0. Without putting pen on the paper, you cannot. So otherwise you have to calculate and check, but determinant will be 0. Sometimes you'll be asked to find out the determinant of some 4 by, that is 5 by 5 matrix also. You may be asked to answer. Then you need not waste your time. Check accidentally if it is skew symmetric. If it is not skew symmetric, you will have to do it. Okay, if it is upper triangular, lower triangular, or skew symmetric matrix, then only you can use this trick. And one more thing is, whatever you are taking here, 3, 4, 5, for example, opposite you should have here, minus. They should be vertically opposite, should have opposite sign. There may be zeros also. Or here, whatever I am taking here, this is which position? A4 to A2, 4, I should have same. So here, if I take 3, A2, 4, here I should take minus 3. So some matrix which is skew symmetric. Suppose you are having skew symmetric matrix, odd order, then automatically, without putting pen on the paper, you can answer. This is principal diagonal, 0, 5 by 5, 1, 2, this is 6, 3, 4, 5. This is principal diagonal, 1, 2, 3, 4, 5, 0, and these two are having opposite signs. And these two are having opposite sign. Aij equal to minus Aj is satisfied. So what is the determinant of this means? Automatically you can write C. Because this is skew symmetric. 5 by 5 skew symmetric. Matrix is 5 by 5, odd order, skew symmetric. This is the principal diagonal, 0, 0, 0, 0, 0. 5 zeros. 5 zeros. So then for this matrix, you can see determinant is 0. So if it is odd order, and if you want, you can check after going to after this class, you can check, calculate and check. It will be automatically true for any odd order skew symmetric matrix. Okay, this is one of the best examples. Now, let us go for now the next concept, that is rank of the matrix. This plays a very, very important role. And one more thing, we have seen some properties of determinant. That is, if a row is added to another row, then what happens to determinant? That also we have seen earlier. That application also, if we can do it, here one more is given, this bit. This bit is having again another interesting question. Let us see. So here, I hope you can see. When you look at this question, I'm doing this question. If A is 3 by 3 non-singular matrix over the field of R, and the determinant of the matrix 5 A inverse is 25, then determinant of adjoint 3A is, look at the question, dimension of the question. Look at this. So we have properties of determinants. What do we want? Determinant of adjoint 3A. Adjoint 3A. What is the order? 3 by 3. N is 3. So N is 3. 3 by 3 matrix. So what is determinant of adjoint A formula? Det A to the power of N minus 1. Where N is 3. Instead of A, you are having 3A. Instead of A, you are given 3A. What is adjoint A formula? Det A to the power of N minus 1. So you are having 3A. Det 3A to the power of 2. 3 minus 1, 2. So we'll come back to this. Most of the students will write 9 into det A square. That is the mistake generally they do. So A is which order? 3 by 3. First we will calculate what is this. You know, this is in the form det Ka. What is det Ka? In the beginning I told you K power N into det A. Very important. Det Ka is K power N. What is N? Order of the matrix. So this into det A. Whole square. Be careful here. Most of the students will write 3 into det A. So be careful. This is in the form det Ka. K power N, N is 3 into det whole square. Now 3 power 6 into det A. So we have to calculate det A now. How to calculate det A? What is given? The determinant of matrix 5 A inverse is 25. So you are given determinant of A inverse. Is it not? 5A inverse. So determinant of given determinant of 5A inverse is 25. Again, students, they will take this out. Again, very important. When A is of order 3 by 3, A inverse also will be of order 3 by 3. Again, det Ka formula. What is det Ka formula? K power N into det A is 20. Be careful. If you write 5 here, again answer will be, you will get some answer that will be there among options. So be careful. Det Ka is K power N into det A. Instead of A, you are having A inverse. No, this will be that A inverse 25 by 5 cube. That is 125. 5 into 5 into 5. 1 by 5. 5 cube is 5 into 5 into 5. So what is det A inverse is 1 by det A. What is det A? 1 by det A inverse. Or det A inverse is 1 by det A. So det A inverse is 1 by 5 means 1 by 1 by 5, which is 5. So det A is 5. Det A inverse is 1 by det A or det A is 1 by det A inverse. Formula, relation between them. Substitute here. This is what we want. Det of adjoint 3A. This is what we want. 3 power 6 into det A square. Substitute here. Then you will get adjoint 3A is 3 into det A square. 3 power 6 into det A square, which is 3 power 6 into 5 square. Which option correct? 3 power 6 into 5 square. Which option correct among you can see the option 3 power 6 into 5 square. D option is the correct. Someone please mute. Please mute, ma'am. 3 power 6 into 5 square. Okay. So which option is correct? D option is correct. So if you do mistake anywhere, you will get one of these answers. So a 3 by 3 non-singular, 5A inverse is 25 and determinant of adjoint. So determinant of adjoint 3A formula we have used. That A is this formula we have used. First of all, det of adjoint A we have calculated, and then we went for determinant of adjoint 3A. What is given? Det of 5A inverse. From there we got det A, then we substituted back. So this is also one of the applications of a concept which we have done earlier. Next. One more interesting question is there. With that, I will close this and enter into rank of the matrix concept. Number of solutions. So our main aim is why to find rank is. Here also one question is there. After the class, you can try 4 by 4. Determinant of adjoint A is 64. Then determinant of 3A square is. One such bit is given. We can take this as homework. You can try this. When I share this document, it will be there in that. You can take. Now, this is the one. This you can. Okay. Let us go for now. One of the or concepts, that question not there. Next week I'll discuss. So if a row is added to another row, what will be the determinant like that? Okay, it's not here. I'll get next week. Next, let us go for now rank concept. Concept of rank of the matrix. Rank of matrix. How to define? So there are two ways of defining this. One way is rank of the matrix based on determinant. Second one is based on echelon form. So for small matrices, it is waste of time applying echelon form. Therefore, better use determinant concept. So you should know determinant concept. Rank of the matrix. So if A is equal to 0, that is null matrix, then the rank of A is taken as, it is generally denoted by row A. Row means rank. A is taken as 0. If A is a null matrix, that is 0 matrix, then that is rank of A is 0. So if A is non-zero matrix, that is at least one element is not 0, comma, determinant of A n by n, I am talking about square matrix, not 0, then rank of A is equal to order of. This order becomes the rank. If the determinant is not 0, rank of A is n. Somebody says, if it is 0, then det A is 0. A is not 0, but det A is 0. Det A is 0, A is not 0, but det A is 0, it's n by n, then rank of A is less than n. So if the determinant of n by n matrix is 0, rank will be less than n. If it is equal to n, if the determinant is not 0, rank will be equal to n. If it is 0, rank will be less than n. So how this question will be given is, if question, if A is a 3 by 3 matrix, A is 3 by 3 matrix, with a dead 0, with not dead 0, the rank of A is equal to 2, comma, A is equal to sum x 1, 2, 0, 1, 1, 1 minus 1, 3. Then x is options will be good. So if A is 3 by 3 matrix with rank of A is 2 and A is this, then x is. Options will be given, data inadequate also will be there. So what are the what are the options? 0, 1. What are the values? Values of x. C, none. D, data inadequate. Data inadequate means data not sufficient to answer this. Information not sufficient, inadequate. Then which one to answer? None means neither 0 nor 1. Data inadequate means we cannot determine. That is, data is not sufficient to answer this question. We cannot conclude anything. That's what it is. So, what is the interesting part of it is, given such questions, observe, what is the order of A? A is 3 by 3. So, rank of A is 2 means, what is the order of A? 3 by 3. Rank is less than n. What is n? 3. N means order of the matrix. Rank is 2. What is the order? 3. Rank is less than 3. Rank less than n, then determinant is 0. Both the sides it is true. If determinant is 0, rank is less than n, rank is less than n, then det A is 0. Both the sides it is true. If and only if statement. So, n is less than 3 means determinant is 0. Rank of A less than n means determinant is 0. So, determinant of x12 is 0. This x12, 0, 1, 1, 1 minus 1, 3 is 0. Now, expand. You can expand along any row or any column. You do as you wish. But we should get the same answer. But again, column wise I have expanded. 3 plus 1, 0 and anything 0, 1, 1, 2, 1, 1, 1 minus 2. I have taken column. 4x minus 1. X is 1 by 4. So, 1 by 4. 0, 1, none. Data. Data is sufficient. We could get the answer, but it is not there. So, C is the data. Rank of A is equal to 2. So, rank of A 3 by 3 matrix is 2, less than n. So, det A is 0. So, remember, this is an if and only if state. So, if the determinant is 0, rank will be less than n. Rank less than n, determinant will be 0. It's an if and only if state also. Det A, rank of A is less than. both the sets. So if it is not 0, rank becomes order. Less than n, then rank becomes determinant be 0, rank is less than. This is how you can see the application. So for example, this is for 2 by 2, for 3 by 3, okay. But if it is, I'll give you some questions using this. Ranks, find ranks. Ranks of the following matrices are. Following matrices. First one. We'll take small matrices. I'm taking only square matrices at present. At present, only square matrices. And later I'll go for rectangle also. Any one of you, if you can answer, start answering. Six. A. Then note down and you too can try. 1 a square, a power n minus 1. 1 a square, a power n minus 1. 1 a square, a power n. N by n. Let us answer. So, let us follow determinant concept. Here, what is the determinant of this? We have to find. And what is the rank of the matrix? So, let us go for first one. 1 minus 1, 1. Any one of you, can you tell me what is the answer?
2.
1 minus 1, 1.
2, sir.
2, 2, 1, 1.
2, madam.
2, 1, 1.
First one rank
Then,
2.
yeah, 2 minus 2, 2. Let us. 2 minus 2, 2. So, what is your observation?
First and the third rows are same.
So, determinant is 0.
Identical. Determinant
Because
is 0.
first and third rows are
Third rows
multiples of
identical.
each other.
Multiple of each
Because
other are identical.
R1 and R3 are multiples of each other.
So determinant
So
0,
whenever they are
therefore,
multiples of each other are bearing same ratio, then we say determinant is 0. So rank is less than 3. Less than 3 means what are the possibilities? 0, R1, R2. These are the possibilities. When is it 0? When everything is 0 only, rank is 0. So this is not possible. At least one non-zero element is there, rank cannot be 0. Rank is 0 only when everything is 0. So it is either 1 or 2. How to know? How to break up the tie? Yes, here we have the concept. So how to find out if the determinant is not 0, rank of A equal to order. If it is less than that, then it is either 1 or 2. Which is greatest is 2. So go for 2 by 2 submatrix or minors. How many minors this will have? 9 minors we have discussed earlier.
out of which anyone
So
is
at least
applicable.
one non-zero minor is there, rank becomes 2. There are 9 minors which you can find. What is meant by minor? Close this row, close this column, take the determinant of remaining matrix. So this is any 2 by 2 minor. If it is not 0, then we say rank is 2. If all 2 by 2 are zeros, then rank is less than 2. Less than 2 means only choiceless choice 1. So 2 by 2 minors we have to find. How to find minor, ma? Take this 1 minus 1, 2 minus 1. This is 1 minor. You can take minus 1, 1, 1, 1. Or you can take 1, 2, 1, 1. Or 2, 1, 2 minus 2. How to find minors? If I want minor of 1, close this row, close this column. Remaining 2 by 2 matrix determinant is called minor. So if I want minor of minus 2, I will close the row in which it lies, column in which it lies. Or you can take arbitrarily any 2 by 2 matrix. Submatrix it is called. So let us go for any one of them. One which is appearing is 1 minus 1, 2, 1. This is the minor for which matrix? This we are closing, this we are closing. So for this element, this is the minor. For any element, take any two adjacent or 1, 2, 1, 1. You can take minus, which is 1 plus 2, which is 3, not 0. If you can find one of the 2 by 2, which is not 0, then rank of A becomes the order. That order. What is the order of this? 2 by 2. So rank becomes 2. Suppose all minors, if you take, they are zeros, then it is less than 2. That case also I will discuss. So find out if suppose this is 0, then you have to go for another minor. How many are there? 9 minors are there. At least one of them is not 0. Rank becomes 2. So here, I think all of you know what are all the minors here you can get? 1 minus 1, 2, 1. This is one minor. What is other minor? Minus 1, 1, 1, 1. Like that, you can get how many minors? 9 minors you can get. You can take these two, these two, these two, this and this, this and this. Like that, you can have 9 minors. If all of them are zeros, rank less than 2. At least one of them is not 0, stop. If it is 0, go to next minor. If that is also 0, go to next minor. If all such are zeros, then rank is less than. If at least one of them is not 0, then it is rank is 2. So for this, rank is 2. For this 1, 1, 1. Any doubt in this? అర్థమైందా? ఎవరికైనా అర్థం కాకపోతే please ask. I will explain once again. After doing all these questions, still if you have doubt, I'll do some more. This is A. For this, by looking at the matrix itself, we can say that A is 0. Why it is 0? Because any two rows or any two columns are same, then we have discussed property, determinant becomes 0. So 3 by 3 determinant is 0, so rank is less than 3. Less than 3 means either 2 or 1. It cannot be 0. Why it cannot be 0? Rank is 0 only when everything is 0. So determinant is 0. So rank is less than 3, definitely. Less than order. Less than 3 means it can be either 0 or 1 or 2. 0 or 1 or 2. It cannot be 0 because it is not a 0 matrix. If it is 0 matrix only, rank is 0. So either 1 or 2. So you have to go for highest. Highest is 2. As I said, you have to go for 2 by 2 minors. So you can take any 2 by 2 minor. Everything will be 0. You can see AD minus BC, AD minus BC, 2 by 2 determinant, all 2 by 2 submatrix determinants. What is meant by submatrix? If you remove a column and row, whatever you get remaining, that is called submatrix. So 2 by 2 submatrices you can take. This is one submatrix. This is one submatrix. This is one submatrix. This is one submatrix. First and last together. Like that, you can get 9 minors because all are same. Determinant for every 2 by 2, if you take, they are all zeros. So that means all 2 by 2 minors are zeros. So rank cannot be 2. What is the only possibility? Less than. This is 1. So rank of A is 1. It is 1 not because of this one. You can have 2, 2, 2, 2, 2, 2, 2, 2, 2. Then also rank is 1 only. If you have 3, 3, 3, 3, 3, 3, 3, 3, 3, also rank is 1 only. Because it cannot be 0, it cannot be 3, it cannot be 2. So only possibility is rank is 1. So whenever you have a non-zero element, when everything is same, rank is 1. Remember that as shortcut. So shall I give that shortcut? So if if K is not 0, then rank of any matrix of any order, K, any order, any square matrix. Need not be 2 by 2, need not be 3 by 3. It can be any n by n matrix. Rank of this matrix is 1. Shortcut. So from next time, you need not do. By looking at that, you can say, when everything is same, square matrix, if it is not 0, then automatically what is the rank? 1. So, for example, in the exam, you are asked to find rank of, for example, rank of some matrix is given to you. Then don't be too sincere. Don't start doing the question. Without putting pen on the paper, you can answer. What is the rank? It is 4 by 4 matrix. What is the rank? It is not 0. So rank is automatically 1.
1.
1. If it is not 0, rank is 1. Next. Understood, no? So this is the technique, shortcut. Next. Let us go for third question. 1, 2, 3, 0, 1, 1, 0, 2, 2. 1, 2, 3. Next question. 1, 2, 3.
Rank 3, madam.
Rank 3. Let us see. What is the question? Can you tell me? 1, 2, 3.
1, 2, 3, 0, 1, 1, 1.
0,
0, 1, 1, 0, 2, 3.
0, 1, 1, 0, 2, 3. 0, 1, 1, 0, 2, 3. This is the one. So for this, what is the rank means? We have to find the determinant. So in this, it is not upper triangular, no property. These two are equal, but here it is 0, it is not 1. So we have to expand. Shortcut will not work. So if expand the determinant, you can expand along any row or any column. Let us expand along any column. Plus first. This is what will you get? This is nothing but 1, 1, 2, 3 return. Remaining all zeros. So 3 minus 2, which is 1, which is not 0. Therefore, rank of A is determinant of A 3 by 3 is not 0. If it is not 0, then rank is order. What is the order? 3. Order of the matrix. So rank is 3. For any order matrix, if the determinant is not 0, then rank becomes equal to order. Next one. You can see 1, 0, 0.
ర్యాంక్ 2 అవుతుంది కదా మ్యామ్
అమ్మా
మ్యామ్
దేనికి
ర్యాంక్ 2 అవుతుంది ఇప్పుడు
దీనికా
చెప్పిన ఎస్
దీనికా
మ్యామ్ ఎస్
ఎందుకు
మ్యామ్
అవుతుంది ర్యాంక్ 2 ఎందుకు అవుతుంది దీనికి ఇది
Rank
3
3
by 3 డిటర్మినెంట్ నేను చేసింది 3 by 3 డిటర్మినెంట్
ఓకే మ్యామ్ ఓకే
3 by 3 డిటర్మినెంట్ ఇది 0 ఇంటూ ఎనీథింగ్ ఇస్ 0 కదా అందుకే వేయలేదు నేను ఐఎమ్ ఫైండింగ్ 3 by 3 డిటర్మినెంట్ ప్లస్
ఓకే మ్యామ్
మైనస్
ఓకే
ప్లస్ 3 by 3 డిటర్మినెంట్ సో ఆర్డర్ is 3. This is the determinant of 3 by 3 matrix. So rank is 3. Next. దీనికి చెప్పగలుగుతారు ఎవరైనా వితౌట్ పుట్టింగ్ పెన్ ఆన్ ద పేపర్ యూ కెన్ ఆన్సర్ ఫోర్త్ వన్ ర్యాంక్ ఏంటమ్మా
Rank 3.
ర్యాంక్ 3 ఎందుకు
Lower triangular matrix.
డట్ ఏ ఎలా కనుక్కుంటారు దిస్ ఇస్ ద లోయర్ ట్రయాంగులర్ మ్యాట్రిక్స్
Product of
ఇది చూడంగానే
principal
గుర్తుపట్టాలి దిస్ ఇస్ లోయర్ ట్రయాంగులర్ ఇది ప్రిన్సిపల్ డయాగ్నల్ దిస్ ఇస్ 1 this is 1 1 1 0 1 0 0 1 2 0 0 1 3 this is principal diagonal above 0 if above the principal diagonal 0 means lower triangular below 0 means upper triangular above and below 0 means diagonal for all the three how to find determinant product of the diagonal elements so what is the determinant of this matrix 1 into 2 into 3 that is nothing but 6 determinant is 6, not 0. 3 by 3 matrix, determinant not 0. So rank is 3. So 1, 0, 0, fourth one, very important concept. Fourth one, a determinant of what is that matrix?